We previously looked at the angle relationships when I have two lines crossing each other. So we ended up with a linear pair where one angle plus the other is going to give me 180. We also were introduced to the concept of vertical angles, in which angles across from each other are going to be the same. What I'm going to do today is I'm going to add a second line and another. I'm actually going to add two more lines. One is going to be along the same direction sort of as the other one, and one is known as a transversal, cutting through the two lines that are within the same plane. So we're going to get to our definitions. What a transversal is: a line that intersects two or more coplanar lines. So if I take a look here, we can see line M and line L are running along sort of the same direction from left to right a little bit, and then line T cuts through the two of them. The transversal is the one that cuts through the two other lines. So in this case, line T is what's known as our transversal. And what happens is we can see that 8 different angles are created here. So we got 1, 2, 3, 4, 5, 6, 7, 8. And there is a specific relationship between these angles. Corresponding angles are the non-adjacent angles lying on the same side of the transversal, one exterior and one interior. So if I take a look at that, again, corresponding, they are on the same side of the transversal, but on opposite sides of the two lines. So one is inside, one is outside. So in terms of corresponding, we can say angle 5 and angle 1, because they are on the left side of line T. 5 is on the inside, 1 is on the outside. We also have angle 7 and angle 3. Again, left side of line T, 7's on the outside, 3 is on the inside. We got angle 2 and 6, as well as angle 4 and angle 8. Alternate interior angles, not adjacent interior angles lying on the opposite side of the transversal. So alternate interior, so they are inside our lines on opposite sides of the transversal. So angle 5 is on the inside, and then angle 4 is on the opposite side of the transversal, on the inside of line M. And then the other pair of alternate interior would be angle 6 and angle 3. Alternate exterior angles, they're the same thing as the alternate interior angles, only they're going to be on the outside of our lines. So angle 7 and angle 2. So 7's on the outside on the left-hand side of the transversal. Angle 2 is on the outside on the right-hand side. And then our other alternate exterior would be angle 8 and angle 1. Now typically, if we know one, we know them all because we have a linear pair created. So if I knew what angle 1 was, I could say what angle 3 is, and the other angles are going to be the same. So 2 would be the same as 3 because they're vertical angles. 4 would be the same as 1, and we just go back and forth alternating the angles. Now if I have two parallel lines cut by a transversal, so in this case we see we have two parallel lines cut by a transversal, we end up with some unique scenarios. We are always going to end up with one of two situations. We are going to end up with angles that are going to be the same, or they are going to be supplementary and add to 180 degrees. So corresponding angles, again, same sides of the same line. So notice angle 7 and 5 here. They are both on the bottom of our transversal here, and they are to the right of our parallel line. So 7 and 5 being essentially the same position, they are going to be congruent. They are going to be the same. So angle 7 is equal to angle 5 in this particular case. And we can use that for every corresponding angle pair as well. So we could say these two corresponding angles that I just marked in blue, I could say these two angles here are going to be the same. We already said 7 and 5. And we also have these two that I just marked in green. They are also corresponding angles because they are in the same position on the same lines. The green ones, for instance, are underneath the transversal and to the left of the parallel lines. The alternate interior theorem states if I have two parallel lines cut by a transversal, then alternate interior angles are congruent. So let's say these two lines are parallel. Then we can say alternate interior angle 8 is equal to angle 6. We also have the option of the other two alternate interior angles. They are also going to be the same as well. Consecutive interior angle theorem. If I have two parallel lines cut by a transversal, consecutive interior angles are supplementary. So this means if my angles are on the same side of the transversal inside my parallel lines, like angle 4 and 5 here, if I add them up, I'm going to get 180 degrees. And I could say the same thing for the up above angles. If I were to add these two together, whatever they may be, I'm going to get 180 degrees. And then alternate exterior angle theorem, same thing as alternate interior angle theorem, states two parallel lines cut by a transversal. In this case, the exterior angles are going to be congruent. So angle 1 is going to be equal to angle 3 in our case. And we could also say the other pair of alternate exterior angles are also going to be equal. And we can use these relationships to find the angle measures, and we can find missing variables. So for instance, we got a few problems here. We need to find x. For this one, we are told angle 4 is 2x minus 17 and angle 1 is 85. So in our case, angle 4, we can label it 2x minus 17. Angle 1 is 85 degrees. We have to determine what the relationship between the two are. So again, as I stated before, when I have two parallel lines cut by a transversal, you're going to end up with one of two situations. The angles are either going to be equal or they are going to be supplementary. They're going to add to 180. So in this case, they fortunately marked off the angles. They color-coded the angles that are going to be the same. So the ones that are in blue are going to be equal to each other. The ones that are in red are going to be equal to each other. So I see 1 is red, 4 is blue. Therefore, they are not congruent, which means they must be supplementary. They're going to add to 180 degrees. So we can say 2x minus 17 plus 85 is going to give me 180 degrees. If I add my like terms, we get 2x and 68. It's going to give me 180. I'll subtract 68. So I end up with 2x is equal to 112. And I'll divide that by 2, so we got 2x is 112. We divide by 2. It should be 112. And we get x is equal to 56. And we found what we were looking for. We found x. Next problem, we are told to find y if we are told that angle 3 is 4y plus 30 and angle 7 is 7y plus 6. So we can go ahead and label them. 3 is 4y plus 30 and angle 7 is 7y plus 6. So we take a look at the relationship. Again, color coding tells me 3 and 7 are going to be the same. They're both red. However, in terms of what the relationship is, they are on opposite sides of this transversal, so they're alternate, and they are on the inside of our parallel line, so they're alternate interior angles. Again, they are going to be congruent, so I just set these equal to each other. 4y plus 30 is equal to 7y plus 6. And I'm going to solve for y. It's always easier to move the smaller variable over. So between 4 and 7, 4 is smaller. So 4y, we'll subtract 4y. And we end up with 30 is equal to 3y plus 6. We'll subtract 6 from both sides. And we end up with 3y is equal to 24. And last but not least, we divide by 3. So we get 8 being our y value. So again, we were told to find y. We found y. And we can move on to our next relationship. If angle 1 is equal to 4x plus 7 and angle 5 is equal to 5x minus 13, we need to find out what x is equal to. So angle 1, 4x plus 7. Angle 5 is 5x minus 13. So we have to determine what the relationship is. Again, color coding tells me 1 and 5 are going to be the same. But if I take a look at the location of our angles, 1 and 5 are on opposite sides of our transversal, so they are alternate, and they are on the outside of our parallel lines, so they are alternate exterior angles, which based on our theorem states that they are equal. So we'll set them equal to each other here. 4x plus 7 is equal to 5x minus 13. And just like before, it's easier to move the smaller x, so we'll subtract 4x from both sides. So we get 7 is equal to x minus 13. If we add 13 to both sides, we get 20 equals x. So we were able to find our x value. And then our last problem here, find y if angle 7 is 68 and angle 6 is 3y minus 2. So if we label 7 and 6, 7 is 68, 6 is 3y minus 2. So again, what we want to do is we want to take a look at the relationship. Color coding tells me they are not the same, which means they're going to be supplementary, adding to 180 degrees. But what is the relationship between the two? I see 7 and 6 are on the same side of our transversal, and they are on the insides, one right after the other. So they are consecutive interior angles, and consecutive interior angles are going to be supplementary. They're going to add to 180 degrees. So I will just create the equation. 68 plus 3y minus 2 is going to give me 180 degrees. So I'll combine my like terms. 68 minus 2 gives me 66, plus 3y gives me 180. I need to subtract 66 from both sides, and I get 3y is equal to 114. I'm going to divide by 3. And when I do that, I get y equals, let's see, 3 and 11, 3, 8, 38. We were tasked to find y, and we found the value of y. Now, once in a while, we're going to get an oddball image like this, where they give us this line is parallel to this far line, and they're going to throw in a wonky indent or a dent out. And they ask us to find these different measurements here. So the question becomes, how am I supposed to do this? Well, fortunately, there's a little trick to it. We're actually going to draw a third line. We're going to use a dotted line just because it's more of a reference line rather than a true parallel line. This reference line is still going to be parallel to the other two lines, and it has a special name known as an auxiliary line. Basically, what it does is it helps us create some sort of relationship, like we saw up above. It's going to help us create alternate interior angles, exterior angles, corresponding angles, etc., to help us figure out what each little section is. So notice with this one, we have the two parallel lines. We had a nice little indent here. They drew this dotted auxiliary line. And what happens is the whole way across is known as angle W, but from our line to our auxiliary line, the dotted line, we can say is E, F would be the other section, and so I will use this parallel line and this parallel line to create alternate interior angles. In this case, it'd be 41. And on this side, it'd be 35, and we would be able to find W this way. So how does it look in practice? Find the unknown. Here we have to find angle D. We are told we have parallel line. Here's the transversal. We can actually just kind of sort of extend this parallel line out using a dotted line, and we can extend it out this way. And we have two parallel lines cut by this transversal. So what we have now is, if this is 35, I can say this angle is 35 as well, because they are alternate interior angles. They're on opposite sides here, and they are on the inside of our parallel lines. We also know that D and 35 are a linear pair. So all I have to do is add them to get 180. So I'll subtract 35 from both sides. And we get D is equal to 145. So that one was relatively simple. Now our second one, we have two parallel lines, and notice we have two transversals here, so we have to kind of really pay attention. Again, it's not too difficult. If I want to find E or F, to find E, I'm only going to focus on this top part here. So we already know these two lines are parallel. This is cut by a transversal. What is the relationship between 54 and E? Again, it's only going to be one of two possible scenarios. They're either going to be the same or they're going to add to 180. So if we take a look, we see that they are on opposite sides of that transversal, the one going left to right there. So that means they're alternate. And they are both on the inside of the parallel lines. So we have alternate interior angles. And according to our theorem, they are going to be equal. So E in our case is going to be 54. Now for F, I'm going to focus on this part here, the one that I just circled in blue. And I can't use E to find F because it's in a totally different place. So what is the relationship between 112 and F? Well, it's relatively easy. If I keep alternating, so F is here, I want to alternate to there, I want to alternate to here, and I want to alternate to there. So those are going to be F. And then 112 is going to do the same thing. I alternate, and those are going to be the same degree. So if I take a look here, we see that 112 and F are on the same side of the transversal on the inside. So these are consecutive interior angles, and consecutive interior angles are supplementary according to our theorem. So if I add them together, I'm going to get 180. So all I have to do is subtract 112. And I get F equals 68 degrees. Number 3, I have these two parallel lines up here and on the bottom. I got a nice little indent here where we got G. We were told 144 degrees up here on the top, 56 degrees on the bottom here. Question becomes, how am I supposed to figure out what G is? So this is where that auxiliary line comes into play. So an auxiliary line is nothing more than kind of a created line that I run through that runs parallel to our given lines. So we know these three lines are parallel. So if I have this line and this line parallel, we know if this part is 56, we know this section up here is also going to be 56 degrees. And then the same thing up here. I have parallel line cut by a transversal here. So what is the relationship for 140 in this one? Again, they are consecutive interior angles and they add up to 180. So to figure this part out, we're in my pink. We take 180 and we subtract the 144, which means that is a 36-degree angle up here. So if I want to figure out what G is, again, G is the whole way across. So this part up here is 36 degrees. The bottom part there is 56 degrees. And the whole is equal to the sum of its parts. So all I have to do, 36 plus 56 gives me G, which means that's going to be a 92-degree angle. And again, this comes with practice. Auxiliary lines take a little bit of looking. Sometimes you have to tilt your head to kind of see what's going on here. And sometimes you also have to extend our parallel lines just to get used to seeing everything. 4 is along the same lines. We have two parallel lines here. We have angle of 162, 98 degrees. H, we have to figure out what H is equal to. So again, auxiliary lines come into play. And I can extend these out. And again, I know it's not perfect, but these lines are all parallel to each other. And they continue on. So here we have parallel line cut by a transversal. So in order to figure out what this part is, what is the relationship between 98 and this angle? They are on the same side of the transversal, the left side here, and they are one right after the other. So consecutive interior angles add up to 180. So to find our missing part, so whatever we're missing plus 98 is going to give me 180. If we subtract 98, we get 82. So this part down here is 82 degrees. And then the same thing up here, we're told this part is 162. So we need to find the missing part up here on the inside here by K to find the second part. Again, they are consecutive interior angles. So our other missing piece is, so we use question mark, we'll use X this time, plus 162 is 180. We'll subtract 162. And our unknown is going to be 18 degrees. So if one part is 82 and the other part is 18, that's going to be our angle H. When I add them together, I get 100 degrees is angle H. Sometimes it takes a little bit of thinking again. Number 5, we have angle measures of 117, I, and 129 degrees here. And we need to figure out what I is. So to help us out, extend our parallel lines. And then we can draw an auxiliary line through I. And again, auxiliary lines are parallel to our given lines. So that line is parallel to each other. So I need to figure out what this angle here is from our center angle here to that point. And I need to figure out what the bottom part is. So what is the relationship here? So here we have 117, which means this is 117 degrees. And we have consecutive interior angles here. So again, we can say this is 117 because they are vertical angles. Vertical angles are the same. And now we have consecutive interior. So 117 plus X is going to give me part of our answer. And so they used I. So we'll use J just to make sure equals, well, rather supplementary, not angle J. We know they're supplementary. They add to 180. We'll subtract 117. So our unknown part is 63 degrees. So this top part angle, 63. And again, 129 degrees here on the bottom outside. And again, vertical angles tells me this section down right here is 129. So now we have consecutive interior angles on this part. And again, y, we'll use y this time. Y plus 129 is going to give me 180. If we subtract 129 from both sides, we're going to get a y value of 51. So to figure out what I is, again, I is the whole way across. So I'm going to add 63 plus 51, giving me the value of I. So I end up with 114 degrees as angle I. Six, we have a triangle, parallel lines. It tells us this top line of the triangle and the bottom line out here are parallel to each other. We're told to find M, K, and J here, so we need to figure out what the particular relationship here is. So in this particular case, we have two parallel lines here cut by a transversal. So if I think about it, two parallel lines cut by transversal, if I take a look at M and 46, they are on opposite sides of the transversal on the inside. So we are alternate interior angles, and they are going to be the same. So right off the bat, I can say M is 46 degrees. And now we can take a look at the fact that we have a triangle here, and we know the triangle angle theorem that states all three angles within a triangle add up to 180. And we have 2 out of the 3. So 92 plus 46 plus K is going to give me 180. If I combine my like terms, I end up with 138 plus K is 180. We'll subtract 138. And we get K is equal to 42 degrees. So 46 for M, 42 for K. And now I see from J all the way around, we have a line here. We know lines add up to 180 degrees. So I just add up the three angles that create this line. So we have J, 42, and 46. So J plus 42 plus 46 is going to give me 180. Add my like terms. J plus 88 is 180. If I subtract 88, I get 92. So J equals 92 degrees. So we found our three angles, 92, 42, and 46 degrees, using previously learned vocabulary terms. Number 7, parallel lines cut by a couple transversals here, and so we just kind of take a look at what we are dealing with. So parallel line here, parallel line there, cut by a transversal. Let me make that a little bit better. So we can say that 37 is part of our issue, same with 44. And what we want to do is we want to take a look at the relationship. So N is not part of the parallel lines cut by transversal. So we should probably add an auxiliary line here through the center. So now we have 37. I can now say this is 37 degrees here. And if this is 37, vertical angles means this part is 37. They are across from each other. And then if I take a look at the other side, I see I have a second transversal. So the black is the transversal for here. And let's use purple. So the purple transversal goes the other way. So 44 alternate interior angles tells me that this part is 44 as well, which means vertical angles. This part is 44. So what I want to do now is I just want to add my two angles together. 44 plus 37 is going to give me angle N. And when I add them together, I'm going to get 81 degrees is angle N. Number 8 looks kind of funky. I have a straight line, and then I got two pairs of parallel lines. So this first line here with one arrow pointing off is parallel to the other one. And then the two V's is parallel to the two V line as well. We need to figure out what P is. We need to figure out what Q is. So first thing, I'm going to take a look at my parallel lines that are 2. So this line and this line here being cut by transversal. So what I can do is I can alternate through 68. This tells me this is 68, and this is 68, and this is 68. And then alternating the 94, 94, 94, 94. So using that, we already know that Q, well, actually I can't say that because Q is only this part. So in order to figure out what Q is, because the 94 is the whole way, is 94, and we need to know what Q is, we need to know what P is. Fortunately for us, we have 3 angles here, and 2 of them being numbers. We have a linear pair, so that means we just have to add 94 plus P and 68 to get P. So I combine my like terms. 94 and 68 is going to be 162 degrees. And we know this is equal to 180. So I subtract 162, and we get P is equal to 18. So now we know the inside part here from my parallel line, my single parallel line to the double, is going to be 18. So to figure out Q, we know the whole way is 94. It's not 94. So what we want to do here is we want to take 18 away from 94. So when I do that, 94 minus 18 is 76 is equal to angle Q. And then number 9, the last one here, we have parallel line. Parallel line, angle R. We are told this is 96, this is 130 degrees down here, and we need to figure out what R is. So this is possibly needing 2 auxiliary, well, just 1 auxiliary line. Usually we run an auxiliary line through where the line kind of bends a little bit. So we are told the whole way here is 96. And we need to somehow figure out what R is equal to. So parallel line cut by transversal, we know that this little section here is going to be R because they are alternate interior angles. So the question becomes, how am I supposed to figure out what this bottom part is? Well, here we have 130 on the inside, and we have this angle on the inside as well. They are consecutive interior angles. So this means they will add up to 180. So if we call this angle X, we know that 130 plus X is going to give me 180. If we subtract 130 from both sides, we get x equaling 50 degrees. So now that we know the two parts and the whole, one part is 50, the other part is r, the whole way is 96. If I add up my two parts, 50 plus r, I'm going to get the whole thing, 96. If I subtract 50 from both sides, we get r equals 46 degrees. And then we can use auxiliary lines to find the unknown angles here. For instance, parallel line, 110, 80 degrees. We have semicircle, that's 310 degrees, and we need to figure out what A is equal to. So got a little bit of legwork here. So draw an auxiliary line through wherever it indents. And again, they are all parallel to each other. So this is parallel, parallel, parallel. So we know alternate interior angles. This is going to be A as well. And circle is 360 degrees. So we know the whole way is going to be 50. And this part being A. Up top, we have 110 degrees. We have 80 degree being the whole way. Well, we know consecutive interior angles are going to be 180 degrees. So this section here is going to be 70 degrees. 110 plus 70 makes 180. And then the bottom part, again, makes 80. Well, 70 and 80 makes 10. Which means if this angle is 10, alternate interior angles means this section is 10. So if I add up 10 plus A, I'm going to get 50 degrees. Subtract 10 from both sides, and I get A equals 40. And this is how auxiliary lines can help us figure out, using alternate interior angles, alternate exterior angles, corresponding angles, consecutive interior angles, and all we have to do is really look at the diagram. It's like a giant puzzle piece, and once we know what the relationships are, we pretty much alternate our angles. So 10 and 10, notice they alternate on our transversal there. And our relationships are always one of two ways. They're either going to be the same, they're going to be equal, or they're going to be supplementary and add to 180.